Hey guys, this is a tutorial on how to remove an element from a slice in Go. Other videos I've seen on this topic, or that include this in their videos, don't go into the syntax of why this works, so I'll break down the syntax and fully explain why it works the way that it does. Anyway, without further ado, let's do a very quick recap of what slices are. Now, as you'll probably know, slices are data structures built on top of arrays. Arrays aren't used that much in Go because they're quite inflexible, but they can be defined like so. The variable name, colon equals, an open and closed square bracket containing an integer, in this case 5, which is the number of elements we want in the array, the word int, short for integer, representing the type of elements the array contains, and finally the open and closed curly braces, acting as a constructor. So variable name, in this case array, equals an array containing 5 elements of type integer, and because we're not adding any values in the constructor, which are the curly braces, it's an empty array. Now a slice, unlike an array, is variadic. That means it can contain any number of elements. The way to create a slice is therefore very intuitive. Just remove the integer specifying the number of elements in the square brackets, and voila, a slice. Easy, right? We can add elements to this after it's been created, but let's specify the elements in the construction of the slice. Let's create 6 elements numbers 1 to 6. Okay, so we have a slice. Of course, Go is a zero-index programming language. That means that the values are different from the indexes. Where we have a value of 1, the index is 0, a value of 2, the index is 1, and so on. Let's pop a representation of that slice up top and keep it there for a bit. If we're trying to retrieve an element from the slice, we can just put the index in square brackets after the variable slice. In this case, we're trying to retrieve the value from index 1 in the slice. The value is, of course, 2. Anyway, that was the quick recap of slices and arrays. Let's remove an element from this slice that we've created. In this case, we want to remove index 2, containing the value 3 from the slice. Let's pop that slice up top again. Now, a quick warning. Go doesn't have an easy built-in way to remove an element from a slice. The syntax is a bit strange, and if you're coming from a dynamic language like JavaScript, it'll seem unfamiliar and a bit weird. But I promise you, it'll make sense as we break it down. First, we'll rewrite the declaration of the slice shown at the top, containing 1, 2, 3, 4, 5, and 6. As we're trying to remove the element with the index 2 from the slice, we'll set I, the index variable, to 2. And here is the line of code to remove the element at index I, in this case the element at index 2, from the slice. So, what just happened? How does this line of code remove index I from the slice? What is that colon syntax in the square brackets, and what on earth are these 3 random dots doing at the end? Why do we add 1 there as well? Well, let's break it down. First, just going to restore the slice back to before we remove the element from it, and let's start with the append function. Append is a function built into Go. It takes as many arguments as you need it to and returns a new slice. The first argument of append has to be a slice, and the rest of the arguments, however many you need, have to be the type of elements you have in the slice that you pass as the first argument. So, we're putting the slice we have up top into the first argument of append. Let's say we want to expand the slice to include some more elements. We can do that pretty easily. The append function will be taking in the slice we're giving it, adding the additional 4 elements, 7, 8, 9, and 10 to it, and then just returning it. This won't do anything yet though, as it doesn't modify the original slice we pass it. It just returns a new slice. We haven't set it to a variable yet, so no change will take place. Let's do that now and set it to our slice. As you'll see, the slice now expands with the additional elements. Awesome! Anyway, that's just an example of how the append function works. It takes the first argument as the slice you want to add elements to, and any further arguments as elements to add to that slice. Let's take away those extra elements, we don't need them. Okay, so now our slice is just being set to itself, so nothing happens. Let's talk about that colon syntax now by taking a brief tangent into what subslices are and how they work. This is a subslice. You can create a new slice from an existing slice by referring to its index values. The syntax for this is a minimum value, which will select the first element index in the slice to go from, and a maximum value that goes up to, but not including the index of that slice. I'm aware that's a bit of a convoluted explanation, so let's demonstrate this with an example. First, let's set our slice to its own subslice. This means that we can get a smaller version of the slice we've already defined. Then, as the minimum value, let's put index 1, and as the maximum value, let's put index 4. As you can see, this has selected 3 elements from the slice at indexes 1, 2, and 3. The slice would now have just 3 elements with values 2, 3, and 4. You can also see that by putting index 4 as the maximum value, it doesn't include index 4, it just went up to it. If we wanted to include index 4, of course, we'd have to put 1 colon 5 instead. If we want to go from the start of the slice up to but not including index 4, we can just remove the minimum value from the declaration. The slice now has 4 elements, starting from the beginning of the original slice. As you probably guessed, you can do the same by removing the maximum value from the subslice declaration. This will return a new slice containing index 1 and going all the way up to the very end of the slice, including all the remaining values. Great! Now that we know this, let's attempt to implement it. Now remember, we're trying to remove index 2 from the slice. We know that we can't directly remove a value from the slice. Instead, we have to create a new slice that simply doesn't include the element we're trying to remove. So we'll quite literally work around it. As a subslice, it's just a slice. Let's modify the slice we pass as the first argument in the append function. We'll make it a subslice of our original slice. In this case, we want to go up to, but not include, the element we're trying to remove. This is index 2, so we'll put that in. Great! We've now selected the beginning of the slice, up to but not including index 2. Logic would dictate then that we want to append onto that the rest of the slice from index 3 onwards. So if we pop a slice here and throw in 3 colon to select the rest of the slice, this would now create a new slice that selects the elements that we need and functionally removes the single element at index 2 that we don't need. But of course, there's a problem. This doesn't work here. The first argument works as the first argument the append function takes is a slice. If you'll remember from the earlier example, the following arguments that append requires aren't slices. They're more of the type of element that the slice contains, so the current approach that we have won't work. So, where do we go from here? How do we turn this slice into something that the append function can use? Well, here's where those 3 weird dots come in. This is now valid and will succeed in removing the element with index 2 from the slice, and make a complete new slice. So, what do those 3 dots actually do? So here's where we take our second brief tangent into variadic functions. So to do that, let's zoom in on this last argument and take a look at it. Those 3 dots are a single piece of syntax and can do 2 different things, depending on where they're used. They can expand a slice into function parameters if they're on the right-hand side of a variable, or they can compress function parameters into a slice if they're on the left-hand side of a type. Let's see how this works in practice. We want a variable named slice. We'll make it so this is just a slice that contains integers, and we'll add 3 elements, 1, 2, and 3. Here's a representation of this very simple slice. Now we want to pass this slice to a function, say do something. Now we could just put this straight in as a slice, but that means we need to handle it as a slice in the function itself, and that's not a great idea for a few reasons. But if we add 3 dots after the slice we've just written, well, it's exactly equivalent to writing the following. So let's create this function so we can show how it's implemented. Here's a simple function that takes 3 parameters, a, b, and c. We call the doSomething function and pass 1, 2, and 3 as the arguments. We'll make it so it prints out a, b, and c. Now, as this is identical to writing and expanding out a slice, we can write that out, and this works. This is interchangeable as the slice is being expanded out into the arguments. Let's pop the slice out of there and declare it as a variable. And voila! This will print the values we expect it to from the slice. It's as simple as expanding out the values from the slice as function arguments and nothing more. But didn't I say we put those 3 dots on the left-hand side of a type sometimes? What does that look like? Well, let's pose a real problem that could happen. What if our slice contains more than 3 elements? What if it contains 4, or 5, or literally any number of elements? The doSomething function can't handle this. Sorry, that's a really big slice, but let's say we have 4 elements, for the sake of simplicity. As we know, this is the equivalent of writing this, which would naturally throw a compiler error, as we're trying to pass a 4th argument into a function that can only take 3. We could just add another variable, like variable d, onto the end of the doSomething function, but then it's hard-coded to take 4 elements, and our earlier slice wouldn't work. Let's use those 3 dots to solve this problem. We still want it to take integers, but instead we'll define it as a variable called values and place 3 dots before the type of int. The current format.println statement will no longer work as the variables a, b, and c no longer exist, but we can just empty that and replace it with the variable values. This will now print out a slice, the slice that we just created, containing the values we've passed it. To make the doSomething function more similar to the way that the append function behaves, we can add another parameter at the beginning that takes in a string. What would we need to add to the doSomething function to accept this new value with a different type? Currently this won't work as hello isn't an integer. Yeah, pretty much. All we have to do is add a first parameter that takes in a type of string, and then the second parameter takes in as many values of the type integer as we need. Let's move this down, pop in another println statement, and show the output of s is the string we've just passed it. Great, so that was variadic functions. Scary name, but actually really quite simple in practice. It can turn any number of function parameters into a slice, and a slice into any number of function parameters so that the append function, for example, can accept what we need it to. So, back to the original slice, and the remove element line of code to put in the final missing piece of syntax. we don't want to have to specify the exact elements we need like we've done here. So instead of :2 in the first subslice and 3: in the second subslice, we'll just add I as the index we want to remove. So this is pretty simple. You want to go up to but not include the element with index 2, so we can literally just replace 2 in this third subslice with I. Finally, seeing as we want to continue the slice after the index we've removed, we just need to add 1 to the I variable. And we're done! We've removed the element to indexed I from the slice by taking advantage of Go's built-in subslice referencing, variadic functions, and the append function. This is exactly the equivalent of writing the following, which is the equivalent of writing this, which is the equivalent of writing this, and you can see how we finally arrive at our new smaller slice. Anyway, thank you very much for watching, and if you have a request for any other tutorials about how to use Go or weird syntax quirks like this one, feel free to comment and let me know, and I'll be happy to make another one. But yeah, thanks. Bye!